Okay, test 1 2 3. Okay, so today we are going to do the SSRF path. Like usual, you guys are gonna watch me study, and I'm gonna take my notes, but I won't show my notes to the stream, but I'll try to explain to you guys to the best of my understanding. And yeah, that's basically it. So let's start. So the path that I chose today is SSRF because it's one of the most basic knowledge that you have to understand probably. Okay, let's start. Okay, let me put up my notes. Let me create a page for the note. So let's start. So what is SSRF? So SSRF is server-side request forgery. Is a web security vulnerability that allows an attacker to cause the server-side application to make requests to an unintended location. In a typical SSRF attack, the attacker might cause the server to make a connection to internal-only services within the organization's infrastructure. In other cases, they may be able to force the server to connect to arbitrary external systems. This could leak sensitive data such as authorization credentials. So yeah, imagine if you have a internal only admin page, so only from locals you can use SSRF to access that. So I'm just gonna write it. Okay. So let's continue. Wow, there are only 1 2 3 4 5 6 rooms. I think this is going to be a quick stream. Okay, let's just continue. So what is the impact of SSRF attacks? A successful SSRF attack can often result in unauthorized actions or access to data within the organization. This can be in the vulnerable application or on other backend systems that the application can communicate with. In some situations, the SSRF vulnerability might allow an attacker to perform arbitrary command execution. An SSRF exploit that causes connections to external third-party systems might result in malicious onward attacks. This can appear to originate from the organization, hosting, or vulnerable application. Yeah, we need to write the impact because during pen testing, what's most important is explaining the impacts of these attacks. Okay, let's continue. Let's So common SSRF attacks. SSRF attacks often exploit trust relationships to escalate an attack from the vulnerable application and perform unauthorized actions. These trust relationships might exist in relation to the server or in relation to the backend systems, other backend systems within the same organization. Okay. Okay, SSRF attacks against the server. In an SSRF attack against the server, the attacker causes the application to make an HTTP request back to the server that is hosting the application via its loopback network interface. This typically involves supplying a URL with a hostname like localhost, a reserved IP address that points to the loopback adapter, or localhost, a commonly used name for the same adapter. Yes, this and this is basically the same. For example, imagine a shopping application that lets the user view whether an item is in stock in a particular store. To provide the stock information, the application must query various backend REST APIs. It does this by passing the URL to the relevant backend API. Okay, endpoint via a front HTTP request. When a user views the stock status for an item, their browser makes the following requests. So they are posting to the stock endpoint and they are giving the stock API parameter with a URL, which is pointing to the stock check /product store ID. What are these? So let's view. Let's open up CyberChef. I wanna see what's that. URL decode. Oh, okay. So stock check. Okay, so they're accessing the stock API to product stock check product ID, which has a parameter called product ID and store ID. Okay, interesting. This causes the server to make the request to the specified URL, retrieve the stock status, and return this to the user. In this example, an attacker can modify the request to specify URL local to the server. Yeah, they can change the stock API. So the stock API is probably a parameter which passes this URL, and the backend, the internal, will then try to access this URL. So if we give it the /admin in the internal, yeah, the internal can access the internal. The server fetches the contents of /admin URL and returns it to the user. An attacker can visit the /admin URL, but the administrative functionality is normally only accessible to authenticated users. This means that an attacker won't see anything of interest. However, if the admin URL comes from the local machine, the normal access controls are bypassed. The application grants full access to administrative functionality because the request appears to originate from a trusted location. Yeah. So normally we need to log into the administrator account, but because this request is coming from the internal network, so the application will just like say that this is safe, but it isn't. Okay. What I meant is the application will just trust the internal request. Okay, let's continue. This is the continued one. SSRF attacks against the server, but continued. Why do applications behave this way? And implicitly trust requests that come from a local machine. This can arise from various reasons. The access control check might be implemented in a different component that sits in front of the application. When a connection is made back to the server, the check is bypassed. Yeah, So the check is not on the inside of the internal function. For disaster recovery purposes, an application might allow administrative access without logging in to any user coming from the local machine. This provides a way for an administrator to recover the system if they lose their credentials. Yeah. So imagine if the administrator count value was changed, like someone have access to the SQL. Imagine if they got an SQL injection, then they change the administrator name or the password. So this helps us for recovery purposes because you don't have to access it using an account. You can just access it from the local server. This assumes that only a fully trusted user will come directly to the server from the server. The administrative interface might listen on a different port number to maintain the application to the main application and might not be reachable directly by users. Okay. These kinds of trust relationship where requests originating from the local machine are handled differently than ordinary requests, often make SSRF into a critical vulnerability. Okay, so this is basic SSRF against the local server. So let's try solving it. So I think I solved this lab at the server side path, the basic server side. So I think solving it again wouldn't be a problem. So let's read the description first to get context. This app has a stock check feature which fetches data from an internal system. To solve this lab, change the check URL to access the admin interface at localhost admin and delete the user Carlos. Okay. So I think we need to boot up our burp suite. So unless, okay, we need to boot up our burp suite. Let's wait. Let's delete that. Delete. Next start. Okay. Hopefully it's that easy. Sounds easy enough. Yeah. Let's boot up our browser. Okay. Let me open it side by side. Then let's take the URL and solve this challenge. So from the description, it says change the stock check URL. So I'm pretty sure when checking the stocks here, you need to provide a URL. See the stock API. It's basically the same from the example. So it returns the value of the stock. But what if we make it access the admin from localhost? Missing parameter. Interesting. What parameter? Are we high? Wait. Oh, my bad. I didn't see that it was just one slash. So can request this in our browser, and let's just copy it, repeat, Then we can delete the user Carlos. Login. Oh, okay. So we actually can't do that, but we can still access the delete function from the local host. Yeah. So we can delete the user Carlos and solve the lab. Nice. That's cool. So let's continue. So this time we are talking about SSRF attacks against other backend systems. Okay, so in some cases, the application server is able to interact with backend systems. They are not directly reachable by users. These systems often have non-routable private IP addresses. The backend systems are normally protected by the network topology, so they often have weaker security posture. In many cases, internal backend systems contain sensitive functionality that can be accessed without authentication by someone who is able to interact with the system. In the previous example, imagine there is an administrative interface at the backend URL 1.192.168.0.68 admin. An attacker can submit the following request to the exploit the SSRF vulnerability and access the administrative interface. Yeah, so because this is a local function in a separate IP address, so anything that can access the IP address should be local. So the application thinks that it's safe because it's coming from local, but it isn't. Okay, so I solved this also. I think it's also from the same path, the server-side vulnerabilities. So let's solve it again. I can't see why not. The slab has stock check feature, the same. Okay, scan the internal IP, the admin interface on port 8080, then use it to delete the user Carlos. So the good thing is we can use intruder to solve the challenge, and this should be very easy. So let's wait for the challenge to load. Hopefully it doesn't take a lot of time. Hopefully. Why is it taking so long? Am I cooked? Okay, so we can take the URL, then put it here, and let's check the proxy. So let's intercept the check. So it's basically the same, but it's just have a different. So what if we take this one and put it into the intruder, but this time it's different because we can't access the localhost. It's the admin functionality is from a different internal IP, so it has a different computer that has the functionality. So we can just change the localhost to the same. It's the same, right? X, yeah. Then in this part, we can add a brute force there, and we can choose the numbers. Yeah, we can try from 1 to 256, stepping by 1. So let's start the attack, and let's just wait for you have solved the challenge. Okay, let's wait. Hopefully one of these works. Okay, so the brute force is actually taking a while. We still have like 200 more, so let's just patiently wait. Let me see that. Oh, I was wrong. No. This attack won't work. Because it's on port 8080. I didn't see that. I made the same mistake. See, interface on port 8080. So we have to do this. All of this again. So. Ooh, so interesting. I actually found the. So I can put this to the repeater. But instead of 0, we can change it to 1. And let's check what's wrong. Missing parameter, which in this part. Or I don't think that is the backend server. I don't think that is. So let's check, and hopefully one of them could make us solve the challenge. Please. Whoop. Oh, never mind. So I think this is taking too much time, so let's check the solution. So we are actually correct, but we just need to wait patiently. So this is pretty annoying. The annoying part is because we don't I don't have Burpsuit Pro, so the brute force is gonna take a while, and it's very annoying. But what if? Can we do like 2 intruders stack? Oh wait, solve the challenge. At which part? Huh? Do we solve it here? Oh yeah. Oh, good thing I did 2 attacks, so it's faster. So I solved the challenge. Nice. That was nice. That took actually a lot of time. Very annoying. Because we need to brute force the back end. Okay, so let's continue. Wait. Okay. Circumventing common SSRF defenses. It is common to see applications containing SSRF behavior together with defenses aimed at preventing malicious exploitation. Often, these defenses can be circumvented. Okay. SSRF with blacklist-based input filters. Some applications block input containing host names like the local host or sensitive URLs like /admin. In this situation, you can often circumvent the filter using the following techniques. Use an alternative IP representations. Yeah, the local host can be represented as a lot of stuff. Register your own domain that resolves to localhost. You can use proof collaborator for this purpose. I think you can use a, what is it called again? Open redirect to redirect it to the localhost. It's the same probably. Obfuscate block strings using URL encoding or case variations. Provide a URL that you control which redirects. Oh, it's different actually. Try using different redirect codes as well as different protocols for the target URL. For example, switching from HTTP to HTTPS URL during the redirect has been shown to bypass some anti-SSR filters. So let's keep that. My notes. Okay, so this SSRF has blacklist-based filter. This lab has a stack filter that fetches data from internal system. To solve that, change the stock check URL to access admin interface at localhost admin. Okay, so the developer actually has 2 weak anti-SSRF defenses that we need to bypass. So let's try to solve this challenge and hopefully it doesn't take a lot of time. Stock check. So let's check the stocks and see. Oh, I didn't intercept it. Okay, let's send it to the repeater. Then let's try. So first, let's just create a normal HTTP request. What happens? So let's render it. Okay, so what about localhost? I'm pretty sure this will be okay. So this is nice because the error is returned like this and not inside of the page. So we can try to bypass this. What about accessing 2.1? Okay, so it actually works. Nice. Then let's try accessing the admin. What if we open up CyberChef? And we can try to URL encode. Maybe. What about case variations first? Let's try using a big. Oh, so that actually already works. You can delete username Carlos. Let's try. Found, follow redirection, and the lab is already solved. Nice, so that's nice. Cool. Thank God that we solved it pretty fast. I was a bit worried that we are gonna take a lot of time here. So let's refresh and see the solve. Nice. Okay, now we are going to learn about whitelist based input filters, SSRF with whitelist based input filters. Okay, so some applications only allow inputs that match a whitelist of permitted values. The filter may look for a match at the beginning of the input or contained within it. You may be able to bypass this filter by exploiting inconsistencies in URL parsing. The URL specification contains a number of features that are likely to be overlooked when URLs implement a ad hoc parsing and validation using this method. You can embed credentials in a URL before the hostname using the add parameter. For example, okay. You can use hashtag character to indicate a URL fragment. For example, okay. You can leverage DNS naming hierarchy to place the required input to a fully qualified DNS name that you control. For example, so this is like creating a subdomain, right? You can URL decode characters to confuse the URL parsing code. Okay, this is particularly useful if the code that implements the filters handles URL encoded characters differently than the code that performs the backend HTTP request. You can also try double encoding characters. Some servers recursively URL decode the input they receive, which can lead to further discrepancies. You can use combination of these techniques together. So let's try saving this to my notes. It might come handy later. Okay, so this is my favorite. So bypassing SSRF filters via open redirection. So it is sometimes possible to bypass filter based on the filter-based defenses by exploiting an open redirection vulnerability. In the previous example, imagine the server submitted URL is strictly validated to prevent malicious exploitation of the SSRF behavior. However, the application whose URL are allowed contains an open redirection vulnerability. Provided the API used to make the backend HTTP request supports redirections, you can construct a URL that satisfies the filter and results in redirected request to be desired backend target. For example, the application contains a open redirection vulnerability in which the URL product, next product, run ID, path, okay, it redirects to full.net. You can leverage the open redirection vulnerability to bypass the URL filter and exploit the SSRF as follows. Yeah, they're just changing the path. This SSRF exploit works because the application first validates the supplied stock API URL is on an allowed domain, which it is. The application then requests the supplied URL, which triggers the open redirection. It follows the redirection and makes the request to the internal URL of the attacker's choosing. Yeah. Wait, let me save that to my notes as usual. Okay, let's continue. SSRF with filter bypass via open redirection vulnerability. It's the same. This lab has stock check feature which fetches the data from internal system To solve the lab, change the stock check URL to access the admin interface at 12.80 admin. So you should remember that it's 12. And delete the user Carlos. The stock checker has been restricted to only access the local application. So you need to find a open redirect affecting the application first. So this actually sounds very fun. So let's try solving the challenge. So let's try viewing the details. Oh, I think I know where the phone is. So let's fill some stuff. Let's check. We should check the functions that are available. So now we have the return to list and next product and check stock. So I want to see what are the requests from each. So return to list, just okay, it's basically returning us with the main page. So let's drop that and drop this one. And what is this? So this is probably where the open redirect is, and this is probably where the SSRF should be. Okay, let's try it first. So imagine, so this should bring us to the wait, let me render it. Why can't I render the application? But basically, see, it's basically another product. But what if instead of making the path the product, what if we put it just into the slash? So let's follow the direction, and now it should wait one. Oh yeah, it should show us the base, the home page. You can see there are the products and the few details button. So let's check that out. Yeah, the products, what the F, few details, or impression costumes, few details. So the open redirection actually works. So what if instead of the slash, we can give it the HTTP 1.9, 1.68, 0.12 on port 8080 to access admin and possibly delete the user Carlos. But instead of giving it the, so let me create it into a URL so I can access this URL. So I created this URL which accesses the product, then goes to the next product, and the redirect will go to the HTTP request, which is the and possibly delete the user Carlos. Hopefully this works, but let's try. So let's copy it here. Invalid URL. Interesting. I don't think we can use this part first. Wait, let me. Oh, I think I know the problem. So let's open our Cyber Chef and also URL encoded. Let me delete that part. URL encode all of the stuff and copy it. Code special characters. This should work actually. 182. Or about double encode? Okay, so let's try deleting that part. 159. How can I know the 159 character? Let me put it to Python then. It's taking a while. So let's create a Python, then put this stock API. What should I call it? Payload. Print the payload, but add 159 to wait, never mind. So the payload should be this part. So let's print the payload. So it's now illegal character. What if we remove the admin first? So let's try removing the admin. Can it work? Why is it giving us invalid? I don't understand. So the admin is actually filtered. What if we give it then delete username Carlos? Can this work? Nope, it doesn't work. So let's try making it again from scratch. Valid URL. Okay, this is a bit weird. So let's make it. But why doesn't it work? I don't understand. It's basically the same, right? I'm a bit confused. Doesn't work. So let's try viewing the solution. Oh, the fault actually happens in the open redirect. So this means we already solved the challenge like this. Is this it? It's not solved yet. So let's just make it access that admin first. So why doesn't it work? Wait, isn't trying to access it from my localhost? So let's just no. Why isn't it working? It's the same, right? Hmm. Oh, so that's why. So I was almost correct, but it. Oh, so yeah, I didn't know. Okay, that's weird. Sad. I almost solved it by myself, but slight confusion from myself. Yeah, that didn't work. Why that was accessing our own local host? It's because it's a open redirect from BT, not an SSRF, because there was no access to the. It was not even trying to access the host that I was giving it. It's only redirecting me to the local host. That's why it's only giving me the local host, and there's no admin there because I didn't create an admin at my local host. Yeah, my bad. There was a very stupid. It was stupid of me. Okay, let's just continue it. So now you're going to learn about blind SSRF vulnerabilities. So blind SSRF vulnerabilities occur if you can cause an application to issue backend HTTP request to a specified URL, but the response from the backend request is not returned in the application's front-end response. Blind SSRF is harder to exploit but sometimes lead to full remote execution on the server or other backend components. Okay. So is it like guessing or I don't know. Let's try. Okay, let me drink. Okay, so what is the impact of blind SSRF vulnerabilities? So the impact of blind SSRF vulnerabilities is often lower than fully informed SSRF vulnerabilities because of their one-way nature. They cannot be trivially exploited to retrieve sensitive data from backend systems, although in some situations they can be exploited to achieve full remote execution. Wait, let me save that also. Okay, how to find and exploit blind SSRF vulnerabilities. So the most reliable way to detect blind SSRF vulnerabilities is using out-of-band OS technique. This involves attempting to trigger an HTTP request to an external system that is control and monitoring for network interactions with that system. So it's basically like a webhook. The easiest and most effective way to use out-of-band techniques is using burp collaborator. You can use burp collaborators to generate unique domain names, send these payloads to the application, and monitor for any interaction with those domains. If an incoming HTTP request is observed coming from the application, then it is vulnerable to SSRF. It is common when testing for SSRF vulnerabilities to observe a DNS lookup for the supplied collaborator domain, but no subsequent HTTP requests. This typically happens because the application attempted to make an HTTP request to the domain, which caused the initial DNS lookup. But the HTTP request was blocked by network level filtering. It is relatively common for infrastructure to allow outbound DNS traffic, since this is needed for many purposes, but blocks HTTP connections to unexpected destinations. Okay. Interesting. So let's continue. So how to find and exploit blind SSRF vulnerabilities continued. Simply identifying a blind SSRF vulnerability that can trigger a out-of-band HTTP request doesn't itself provide a route to exploitability. Since you cannot view the response from the backend request, The behavior can be used to export content on the systems that the application server can reach. However, it can still be leveraged to probe for other vulnerabilities on the server itself or other backend systems. You can blindly sweep the internal IP address space, sending payloads designed to detect well-known vulnerabilities. If those payloads also employ blind out-of-band techniques, then you might uncover a critical vulnerability on an unpatched internal server. Another avenue for exploiting blind SSRF vulnerabilities is to induce the application to connect to a system under the attacker's control and return malicious responses to the HTTP client that makes the connection. If you can exploit a serious client-side vulnerability in the server HTTP implementation, you might be able to achieve remote code execution within the application infrastructure. If you can exploit a serious client-side vulnerability in the server, interesting. So this actually sounds very hard. Okay, so the lab is about with out-of-band detection. The site uses analytics software which fetches the URL specified in the refer header when a product page is loaded. To solve the lab, use this functionality to cause an HTTP request to the public to prevent the academia platform from being used to attack third parties. Our firewall blocks interactions between the labs and arbitrary external system. To solve the lab, you must use burp collaborator's default public server. So I can't actually solve this challenge because I don't have burp collaborator, right? Or see, I don't even have the professional. Wait. This is a bit stressful. Okay, so I can actually solve the challenge, so I'm just gonna see the solution straight because I can't even use the collaborator, so I'll just check the solution and see why community solution. Since the server-side command is okay, you should see some DNS and HTTP interactions that were initiated by the application as a result of your payload. Let's see the solution. So yeah, he accessed the lab. Then he intercepts, put it to the repeater. Oh yeah, I can see that there's a referrer header, right? So he probably changes the referrer header, and after that he will send the request, then view the collaborator. That's basically it, right? If yes, then I should be able to solve it with a collaborator, but I don't have it. Oh, that's it? Okay, so it's actually very easy to do. So that's a bit sad to see because I can't solve it without the web. So let me just put it on my notes so I know next time if I have web premium I'll solve it. That's a bit sad. I'll just skip the lab. Okay, finding hidden attack surface short SSRF vulnerabilities. Many server-side request forgery vulnerabilities are easy to find because the application normal traffic involves request parameters containing full URLs. Other examples of SSRF are harder to locate. Okay, so let me put this on my notes. Okay. Okay. Let's continue. Partial URLs in requests. Sometimes an application places only a hostname or a part of the URL path into the request parameters. The value submitted then is incorporated server-side into a full URL that is requested. If the value is readily recognized as a hostname or URL path, the potential attack surface might be obvious. However, exploitability as well as SSRF might be limited because you don't have control the entire URL that gets requested. Yeah, because we only have partial control, right? That's what it means, right? URLs within data formats. Some applications transmit data in formats that with a specification that allows the inclusion of URLs that might get requested by the data parser for the format. An obvious example of this is the XML data format, which has been widely used in web applications to transmit structured data from the client to the server. Okay. When an application accepts data in XML format and parses it, it might be vulnerable to XXE injection. It might also be vulnerable to SSRF via XXE. We will cover this in more detail when we look at XXE injection vulnerabilities. Interesting. Okay. SSRF via the referrer header. Some applications use server-side analytics software to track visitors. This software often locks the referrer header in requests, so it can track incoming links. Often, the analytic software visits any third-party URLs that appear in the referrer header. This is typically done to analyze the contents of referring sites, including the anchor text that is used in the incoming links. As a result, the referrer header is often useful attack surface for SSRF vulnerabilities. Okay, I'll put that on my notes too, because that sounds cool. Then let's continue. Oh, we finished the lab already? I didn't even notice. Okay, so that's nice. So how many paths did we finish? It's 6, right? 1, 2, 3, 4, 5, 6. So we finished 6 paths already, and it's day 6. Yeah, that's pretty nice. So we finished our path already. How long has it been? Only an hour. Okay, so that's nice. So I hope you guys have a great day. So I'm gonna end my stream here. Thanks for watching. Thank you. Goodbye.